Okay, next we are going to derive an expression for the rate of change of a rotation matrix. We're going to do this in two parts. First, we are going to tell you, give you some general intuition about what kind of form it might take. And then next, in part two, we are actually going to derive that expression in terms of angular velocity, how the rotation matrix changes in terms of the angular velocity vector. Okay, so that's what we're going to do. So let's first, so this is part one. This is not quite a full derivation of the rate of change, but something that points to what it looks like. Okay, so imagine consider a rotation matrix. I don't know, let's call this Q. That represents the rotation of an object. Then, of course, because it's a rotation matrix, by definition, it's orthogonal or proper orthogonal. In other words, Q transpose equals I, the identity, okay, by definition, because it's a rotation matrix. Okay, now let's differentiate both sides. So d by dt of Q transpose equals, well, d by dt of I, the identity matrix, which is just zero, because the identity matrix is just a bunch of constants. Okay, so what is the d by dt of Q transpose? It's going to be, using the chain rule, d by dt of Q times Q transpose plus Q times d by dt of Q transpose. And that's going to be equal to 0. So what does this look like? Let's rearrange this a little bit. Let me do an aside here. AB whole transpose equals A transpose, equals B transpose A transpose. Okay, so if we consider this expression, or one of these expressions, let's say we consider this expression, this basically means, so let's call this 1, from, because of this, because of 2, Q dq by dt transpose equals dq by dt times Q transpose whole transpose. So you can check that. So if you take the transpose of this, you would get this because of this. Check that. So let's call that 3. And then we plug in 3 and 1. So what do we have? So substitute 3 and 1. Substituting 3 and 1, we get dq by dt Q transpose plus this expression now, dq by dt Q Q transpose whole transpose equal to 0. Okay, so what does this look like? So this basically, yeah, if you call this matrix, call U equals dq by dt Q transpose. equation 4 then just means that u times u plus u transpose equals 0, right? So that's what equation 4 is. U plus u transpose equals 0, or u transpose equals minus u. This is basically implies U is a skew symmetric matrix. By definition, if you recall what a skew symmetric matrix is, this is the definition of a skew symmetric matrix. Okay, so what do we say? So let's call this equation 5. In equation 5, we are basically saying that dq by dt q transpose equals u, which is a skew symmetric matrix. That's what we have shown. Or take multiplying both sides by q, we have of course q and q transpose when multiplied gives the identity. So dq by dt, in other words, the rate of change of the rotation matrix is a skew symmetric matrix times the matrix Q itself, the rotation matrix Q itself. Okay, so that's an expression that we've just derived. So what is this Q symmetric matrix? So this is part 2. What is this skew symmetric matrix U? Okay, so what is it? So let's now set up the situation more carefully. Let us say as usual we have frame 0. And then we have a rigid body. We have frame B attached to the rigid body. And this frame B has an angular velocity omega relative to frame 0. Okay, so frame body fixed frame. Has angular velocity omega relative to frame 0, let's say the base frame. Consider a vector G fixed in, or G or R, let's just use R for simplicity, R fixed in frame B, and moving with frame fixed or constant, let's say, right, as we've done in the past, moving with B. Okay, it's got the same angular velocity omega. Now, let's say this vector R is represented in frame B by the components Bx, By, and Bz. Okay, so these are the components of R in this frame. And in frame 0, let's say the components are R x ex0 plus R y ey0 plus R z ez0. Okay, and let's say there's a rotation matrix. There's a rotation matrix that takes us from one frame to the other. So let's say Q is in fact that rotation matrix. Okay, so the B's are constants, and then as Q changes, in other words, as the object rotates, the components Rx, Ry, Rz will change. Okay, so let's differentiate this equation. Let's differentiate it, both sides, differentiating. We get Rx dot, Ry dot, Rz dot equals, well, the B's are just constants. So if you apply chain rule, we are getting Q dot times the B's and then Q times the B dots, but the B dots are 0. So it's basically just Q dot or dQ by dt times the B's, Bx, By, Bz. Okay. Okay, so this is, of course, Q dot is dQ by dt. Now, what is our dr by dt? So if you say R is Rx Ex naught plus Ry Ey naught plus Rz Ez naught, and then we ask the question dr by dt in frame 0 is basically because it's going to be Rx dot Ex naught plus Ry dot okay, but this is also going to be equal to, because this rate of change of R, in other words, R is changing because of the rotation of the body B, so it's basically equal to omega cross R. Okay, we can now write this expression out, this whole expression out, represented completely in frame 0. So the left hand side in frame 0 is basically Rx dot, Ry dot, Rz dot in frame 0. And in the right hand side, if you want to represent this in frame 0, then we want to recall that the cross product can be represented as a skew symmetric matrix. So we're going to represent this omega cross R as a skew symmetric matrix using omega, but omega in the 0 frame. So because we want to be consistent in this equation, what frame we use when we represent things in terms of frames. So that's the skew symmetric analog of your omega. And then R, of course, we want to represent in the 0 frame as well. And that's going to be equal to Q times Bx, By, Bz, or this is basically Rx, Ry, Rz. right? So Rx, Ry, Rz is Q times Px, Py, Bz. So what does that all mean? So let's call this equation 1. Let's call this equation 2. Compare equation 1 and equation 2. The left-hand side is the same. The right-hand side has Bx, By, Bz. And then we have this, and we have that. So essentially Q dot is going to be this whole thing, okay? So Q dot is okay. So this is a skew symmetric matrix based on omega, but based on omega represented in frame 0. Okay, it's using components of frame 0. Okay, so omega represented in, and of course with respect to as well, but more importantly represented in frame 0. Okay.